Our next speaker in this session is Ms. Namita Gupta, founder and CEO of AirVeda, an air quality monitoring startup focused on end-to-end air quality monitoring solutions for both indoor and outdoor environments. Having graduated from IIT, she worked for Microsoft and Facebook in the USA for more than a decade. Ms. Namita worked at Zomato as CPO for a year before starting AirVeda in 2016. She believes in the mission to help people breathe well and live well. She is also on the committee for the Indoor Air Quality Association India chapter and an independent director on the Zomato board. Today, Ms. Namita will talk about the importance of monitoring of IAQ parameters. So delegates, let's welcome Ms. Namita.
So air pollution is, clearly one of the biggest health hazards of our time. It started out as a Delhi problem, then a North India problem, and now more and more data across the world is showing us that 92% of the world, in fact, some of the latest data by WHO shows that 99% of the people population of the world does not live in places that meet the WHO standards. So this is clearly an area which needs a huge focus. Now, unfortunately, a lot of people think that indoor air quality is cleaner than outdoor air quality, but it's often worse than outdoors, because not only indoors do you have the particulate matter which is coming from outdoors, but there's also high carbon dioxide level, high amounts of VOCs which are often created indoors, as a result of which there's a lot of health issues which happen because of indoor air quality. More and more data is also available that there's much greater viral transmission indoors, as a result of which you may be much more prone to catch COVID indoors than outdoors. The data shows how keeping carbon dioxide, temperature, humidity, particulate matter in particular ranges can actually reduce the transmission indoors in case of an exposure. So all these things are making air quality really sort of bring front and center in terms of its importance. Now the good thing is that indoor air quality is a solvable problem, right? People are spending 95% of their time indoors. And while cleaning outdoor pollution will take a long time and a lot of government and policy effort, right? Indoor environments is something we can actually clean much more easier. And we have a lot of experts on this panel right now who are actually working towards cleaning indoor environments. So let me sort of drill into the sort of topic of my talk, which is why is air quality monitoring important? To start, you can't manage what you can't measure, right? So, if you want to actually fix something, you have to first measure it, because, you set up, and this is how I got into air quality monitoring. My first sort of idea was to set up purifiers in my house when I realized air quality was really bad. But how do I actually know that those purifiers are working, that the air quality in my house is actually fixed? So without monitoring, you simply can't know if your solution is actually working. But now if you start looking at air quality, in buildings, right, there are sort of various aspects of, why monitoring is really important. For a client who's going to implement air quality monitoring solutions in their building, they need to see the value, right, for the money that is spent. Is their solution actually creating a healthy environment indoors? They need that data to be able to better operate the building, right? They need to demonstrate the results to the occupants and showcase how the air quality in the building is. They want to be able to get early warnings and alerts when air quality is not good, so that they can fix those in times to provide better health and safety to occupants. And also to be able to benchmark the performance of a particular solution against other solutions of floors or buildings and time periods to figure out the best solution that works for providing clean air in the buildings. And a lot of clients also, want to get green building accreditation, for which monitoring is essential. Now, if you look at a consultant's view, who is working with a client to build an air quality solution, they want to demonstrate the results and cause an effect to clients, so that clients can actually see that their solution improved the air quality in their buildings. Remote visibility, these consultants are not on the site all the time, so they need to be able to remotely view the data so that they can understand that their solution is actually working. If the data starts not looking so good, they need to be able to quickly diagnose and actually resolve these issues before the client actually recognizes that there's a problem. There's an opportunity to deepen relationships with clients by giving them, sort of data up, regularly on how the air quality and the solution that they are implementing is working really well for the client. And then, of course, increase their green building certification credits. Now, one of the things that I constantly hear is, continuous versus manual monitoring. More and more, we are seeing, that monitoring is moving to become continuous instead of manual. Now, the problem with manual monitoring is that if we start looking, and I work a lot in air quality data, both ambient and indoors. We set up monitoring networks all over the country and track air quality data. And what we see is that, air quality data changes not only on a daily or a monthly or a seasonal basis, but even within the day, there are so many changes to air quality data. So if you look at the graph on the side, what you're seeing is air quality data for a particular day, right? And you can see how, depending on what time of the day you actually go and measure the air quality, you may see the air quality to be, much higher or lower than what the exposure of the average exposure of an individual who is occupying that space is. Similarly, if you look at the monthly data, you see so much variation even within the month that, any spot checking gives you a very, very partial view of the actual air quality exposure for an individual who is working in the building. However, it's not true that continuous monitoring completely replaces lab-based spot checking, because, these continuous sensors, you need to check the performance of these sensors. You need to make sure that they are properly maintained. And, and some of the sensors, reference grade sensors are very expensive. So it makes sense. And you cannot set them up for continuous monitoring in all the buildings. So often you want to do, regulatory grade sensors or reference grade sensors. You want to use them for spot checking and then use continuous monitoring for really getting an overall view of monitoring. So let's talk about the monitoring hardware then. So some of the key parameters, that we recommend to people to monitor indoors are PM2.5, PM10, carbon dioxide, TVOCs, temperature and humidity. There are also several other parameters like carbon monoxide, formaldehyde, noise, lux, and others that people monitor indoors. But so some of the key parameters, especially the reset standard and a lot of the other standards recommend are these. Now, for outdoor air quality, every government provides an air quality index to track the quality of air, right, and its health effects. India has an Indian AQI, US has a US AQI, Singapore has their own AQI. But unfortunately, no country today has indoor air quality standards. As a result of which, most of the air quality standards are being created by organizations like IAQ or Reset Standard or Well Building Standard. So depending on, whether you're looking for a particular green building certification or you're looking at a particular standard, I think a very important part of monitoring is to actually pick a standard that you want to use to be able to understand how your building is performing. Once you pick the monitoring standards, the next thing is to understand what sort of monitoring you actually need to deploy in your building. Now, usually we have two kinds of clients. We have commercial interiors, the core and shell. Commercial interiors are clients who want to understand, the air quality that the occupants are breathing inside the building, versus core and shell are usually builders who do not take care of interiors but hand off the building with the HVAC systems and the purification systems to the individual clients. So if you're looking to monitor commercial interiors, then you want to set up indoor monitors, where the people are sitting to really understand what they are breathing. You usually want to set up some outdoor monitors to be able to do indoor versus outdoor comparisons. Like, for example, a lot of times, it's very impossible to meet indoor air quality standards because outdoor air quality during Diwali is like 700 micrograms per cubic meter, right? So at that point, to know that your system is working, the only thing that can help you with that is to know the difference between the indoor versus outdoor air. So if your indoor air is actually 70% or 80% better than outdoor air, that means your purification system is working, even though you may not be meeting the standard. Now, if you're monitoring core and shell, then often people will use duct monitors, which will go into the return and supply air to actually understand if their purification systems are working correctly. And of course, they also, they sometimes use indoor monitors in the HU rooms, or they'll use duct monitors in both indoor and outdoor. Now, in terms of standards for, hardware equipment for monitoring, there's only one standard internationally, which is known as Reset Air Standard. So they provide a standard for indoor and duct monitors. They basically segregate devices between grade A, grade B, and grade C, where grade A are reference grade devices, grade B are commercial grade devices, and grade C are consumer grade devices. And most green building certifications like Reset or Well Building certification, they only allow grade B or grade A devices to be used for this certification. And these, it is very important when you are setting up these sensors in your building, you pick, grade B sensors, because bad data is often worse than any data actually. So, having sensors which have, proper accuracy, range, sensitivity, consistency, that they're calibratable, it's extremely important to get good sensors. So that you're actually understanding the real performance of your building. In terms of deployment standards, we work with reset standard, which basically requires one sensor per 500 square meter of open space, and ensure that you cover 80% of regular occupants, so you actually have a good sense of what 80% of the occupants in the building are breathing. We work with a lot of clients who will put one sensor in one room, and then they will sort of start showcasing that as the real air quality of the building, and that actually is not representative of what people are breathing in that building. The last part of my presentation talks about automation and dashboards. So monitoring is the first step to any type of automation. Ultimately, we need to be able to automate solutions for creating, healthy and energy efficient building. And, earlier this was very sort of, conditional based, right? If CO2 levels go above 800 ppm, then you open, the sort of open the, increase the ventilation and open the actuators and the dampers, right? And let fresh air in. But more and more with developments in machine learning, there's actually a huge opportunity for additional efficiencies in this space to really optimize for buildings that can be truly healthy as well as energy efficient. There are various things you can control, of course, the fresh air, which is based on carbon dioxide levels indoors, but also the PM level outdoors, right? What you don't want is that you open the dampers fully because carbon dioxide levels indoors are high when the particulate matter is really bad outside, because then what you're doing is pulling in a lot of pollutants into the building. So how do you sort of manage that to create a healthy environment, right? Similarly, right, what should your set point temperatures be based on the outdoor temperature, right? So if in the, should your set point temperatures in the building be different based on the outdoor temperature, like during winters and summers, or even during the day. Usually the protocols that are required for connecting for automation with building management systems are RS 485 Modbus, RTU or IP, and then BACnet is sort of the standard protocols for connecting your monitoring systems to building management systems which are used. Finally, now that you have all this monitoring set up, you need proper analytics and dashboards to actually be able to understand the performance of your building and get alerts and notifications, whenever there's a problem, so that you can quickly fix it, as well as, being able to access this stuff, remotely on mobile apps, and being able to showcase this to occupants, which is actually extremely important, for a lot of the clients we work with, who go through a lot of effort to clean up their buildings. They actually want their occupants to know that they're breathing clean air and living, working in a healthy environment, which can be very, very motivating for individuals. So here are some of the key goals, that dashboard systems can provide: real-time system performance tracking to know that your system is working well, quick fault detection and preemptive equipment maintenance, so that that some, like a filter needs changing because the pressure drop is suddenly very high, timely alerts for issues so that they can be quickly resolved before the occupants of the building actually start feeling it, ability to diagnose issues and quickly find the problem by understanding the analytics, remote access through mobile apps, controls, secure access, of course, and then also, they need to be easy to set up, understand and intuitive, and easy to get upgrades, because today's world is such a fast moving place where there's so many improvements happening in technology, which can help you to continue to improve your building performance. So that's all I had in inclusion. We're spending so much of our time indoors, and so much data out there shows how much the air quality significantly affects our health, our productivity, our cognitive ability, and we really cannot fix something that we can't measure. And continuous monitoring, real-time dashboards, alert systems, automation can really ensure healthy and energy efficient buildings of the future.